Welcome to our series. We'll discuss a very simple and effective approach to find general solution for trigonometric equations in this playlist. Thank you. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. Here is a very important video in which we are going to discuss how do we write general solution for a trigonometric equation. Well, in the playlist, you'll find many examples. Our focus will now be on simple equation based on sine and its reciprocal cosecant. So here are 3 questions for you. I'd like you to pause the video, answer these questions, and then look into my suggestions. So once again, in case you want to learn directly from me, you can always send an email on the address given. Let us now look into the general solution of sine equations and also understand the concept. Well, as you can see, question 1 is 2 sine x minus square root 3 equals to x. Question 2, square root 2 sine x minus 1 equals to 0. And then cosecant x plus 3 equals to 5. We should remember that sine x is positive in quadrant 1 and in quadrant 2, correct? So if it has a solution alpha in quadrant 1, then it will also have a solution pi minus alpha. You get the idea. Perfect. So that is how the solutions are related. Now, important thing here is that when we talk about general solution, we also see that the same angle could also be written as a coterminal angle like this, correct? So it becomes now 2 pi plus alpha. You get the idea. But when we come to this side, then it is 3 pi minus alpha. So if I go further, for example, if I go like this, then it is 3 pi minus alpha. So what you see here is that the angle alternates, right? You see it goes, here it is plus alpha, right? Here it is minus alpha. So it kind of alternates. Perfect. So to give you a general solution, what could it be? Well, in general, if I have sine x equals to sine alpha, in that case, x will be equal to not only alpha but n pi, right, plus minus 1 to the power of n times alpha. So this minus 1 is kind of important to understand. It really tells you that if n is even, then you add, right? But if n is odd, then you subtract, so that you are in quadrant 1 and 4 for a positive value of alpha. Does it make sense to you? So with these examples, we'll see how to work it out. Perfect. So let's take up the very first example, which is 2 sine x minus square root 3 equals to 0. Means sine x, let me go ahead in 2 steps, equals to square root 3. Dividing by 2, we get sine x equals to square root 3 by 2. And now to find the solution, we'll draw the special triangle. The special triangle with sides of square root 3 and 2. The angle, as you know, is pi by 3, correct? So this is a special triangle, pi by 3, pi by 6, and pi by 2, where the sine is square root 3 by 2. Sine, as you know, is the ratio of opposite to hypotenuse, correct? So it is positive, as we just discussed. We're looking for solutions in quadrant 1 and in quadrant 2, right? So all these are solutions, correct? This is a solution, that is a solution, right? Similarly, if you go like this, that is also a solution. So we have to now provide a general solution. So general solution will be what? General solution is x is equal to n pi, right? It repeats after every pi, right? However, in coordinate 1, you have to add, and in coordinate 2, you have to subtract. So minus 1 to the power of n, and alpha being pi by 3. Does that make sense? Of course, n belongs to set of integers. So that is how we can write down the solution. Perfect? Great. Now let's look into the second example. I hope it is absolutely clear. You can always send an email on my address to directly learn from me. All my students are doing extremely well. Well, here is the second example. I'd like you to now pause the video, answer the question, and then check with my solution. We have 2 square root 2 sine x minus 1 equals to 0, square root 2 sine x equals to 1, and sine x equals to 1 over square root 2. So sine x being 1 over square root 2 means we are looking into a special triangle whose sides are 1, 1 square root 2, right? And the angle is pi by 4. As you know, the solution now is in quadrant 1 and 2, pi by 4, right? Those are the angles. And the general solution is all the angles which terminate on either pi by 4 or 3 pi by 4, right? Kind of like this, right? So how do you provide the general solution? Well, the general solution is x equal to n pi, right, plus minus 1 to the power of n times pi by 4, where n belongs to set of integers. Clear? So that is how you're going to do it. The last example here, we have two concepts to remember. One is the equation is given to us in cosecant x, which is reciprocal of sine, right? So we know cosecant x equals to 1 over sine x, right? Okay. So let's isolate cosecant x, which will be 5 minus 3, which is 2. Now, since cosecant x is 2, the special triangle is two, and we're looking into 2 over 1, and the angle will be pi by 6, correct? And therefore, the solution for x should be what? Well, solution of x will be n pi plus minus 1 to the power of n times pi by 6. Makes sense? So that is how we are going to solve it. Now, here is a test question for you, which I would like you to try. So the test question for you is, if I have sine x equals to minus of half, in that case, find x. General solution. Make sense? So it is minus half, remember? So the solution will lie now in quadrant 3 and in 4. If that is the case, then how do you write the answer? That is what you need to figure it out. We'll discuss this in one of our videos later. I hope it all makes sense. Feel free to write your comments, share your views. If you like and subscribe to my videos, that'd be great. You can always contact me on the address given. Thanks for your time and all the best.